Imagine the entire universe concentrated into a tiny point, smaller than an atom. This point contained all the matter and energy that exists today. About 13.8 billion years ago, this point exploded. We call this event the Big Bang. The Big Bang wasn't an explosion in space, but rather the expansion of space itself. It's still happening today. Think of a balloon with dots on it. As you inflate the balloon, the dots move apart, just like galaxies in our expanding universe. In the first fraction of a second after the Big Bang, the universe was incredibly hot and dense. As it expanded and cooled, the building blocks of matter began to form. The universe is constantly expanding. This expansion is a key piece of evidence supporting the Big Bang theory. As the universe expands, space stretches. This stretching affects the light traveling from distant galaxies. The light waves get stretched out, shifting towards the red end of the spectrum. We call this phenomenon redshift. Imagine a car horn moving away from you. The sound waves stretch out, making the horn sound lower in pitch. Redshift is similar. The stretching of light waves tells us that the galaxy emitting the light is moving away from us. The farther away a galaxy is, the faster it appears to be moving away. In the first few minutes after the Big Bang, the universe cooled enough for protons and neutrons to combine. These particles are the building blocks of atoms. The intense heat and pressure caused these particles to fuse together, forming the lightest elements, hydrogen and helium. This process is similar to what happens in the core of a star. Under immense pressure and heat, hydrogen atoms fuse to form helium, releasing energy in the process. For a short time, the entire universe acted like a giant star, forging the basic elements that would later form everything we see around us. Over millions of years, gravity pulled together clumps of hydrogen and helium gas. These clumps grew denser and hotter, eventually igniting nuclear fusion in their cores. This is how stars were born. Stars are giant balls of plasma powered by nuclear fusion. Imagine a giant campfire. The heat you feel is generated by the burning wood, which releases energy. Stars are like cosmic campfires, but instead of wood, they burn hydrogen. The energy released by stars provides light and heat to the universe. Section 5. Galaxies, the cosmic cities. Stars didn't form in isolation. Gravity pulled them together into vast collections called galaxies. Our galaxy, the Milky Way, contains billions of stars. Galaxies come in different shapes and sizes, like spirals, ellipticals, and irregulars. Think of a city at night. From a distance, you see the collective glow of millions of lights. Similarly, galaxies are like cosmic cities, filled with the light of billions of stars. These galaxies are not randomly scattered. They are organized into groups and clusters, much like cities and towns on a map. Section 6. Our solar system, a neighborhood in the Milky Way. About 4.6 billion years ago, a giant cloud of gas and dust, called a nebula, collapsed in on itself. This collapse led to the formation of our solar system. The Sun formed at the center, and the planets, including Earth, formed from the remaining material swirling around it. Imagine a spinning disk of dough. As the dough spins, it flattens out and planets form from clumps of dough within the disk. Our solar system is just one of billions of planetary systems in the Milky Way galaxy. Section 7's Earth, the pale blue dot. Earth is a unique planet in our solar system. It is located in the habitable zone, a region around the Sun where temperatures are just right for liquid water to exist on the surface. Water is essential for life as we know it. Imagine a glass of water with a single drop of ink in it. That tiny drop represents the amount of liquid water on Earth's surface compared to its size. This precious water is what makes our planet so special and supports the incredible diversity of life we see around us. Section 8. Life on Earth. From simple beginnings to complex organisms. Life on Earth emerged about 3.5 billion years ago. It started with simple single-celled organisms. Over billions of years, life evolved and diversified, leading to the complex plants and animals we see today. The evolution of life on Earth is a testament to the power of natural selection and adaptation. Think of a tree with many branches. Each branch represents a different lineage of life on Earth. Some branches are short, representing extinct lineages. Others are long and continue to branch out, representing lineages that have survived and evolved over time. Section 9. The future of the universe. The universe is still expanding and evolving. Stars are born, live out their lives, and die. Galaxies collide and merge, creating new generations of stars. The ultimate fate of the universe is still uncertain. Will it continue to expand forever, or will gravity eventually reverse the expansion, leading to a big crunch? Imagine a ball thrown into the air. Will it keep going up forever, or will it eventually fall back down? The future of the universe is a mystery that scientists are still trying to unravel. One thing is for sure, the universe is a vast and awe-inspiring place, and we are fortunate to be a part of its ongoing story.